Hello, I'm Rick Shefchek with Thorvie International Saw and Tool Sharpening Equipment. I'm going to demonstrate today how to solder on new carbide tips using our AV-38 retipping fixture. When you get the retipping fixture, it's going to come unassembled. You'll have your plate and you'll have your center arbor stud, which has 3 different bushings, 5/8, 3/4, and 1 inch for different arbor sizes. This is our stop finger. It's spring loaded, so when you index the different teeth, it'll always set back into the same location. You'll have 3 table legs and then also a side saw support for your larger diameter saw blades. Now, there's the socket head cap screws will be threaded into the table legs, and there'll be 3 hole locations that are counterbored, so that way they sit underneath the fixture. So you can put your socket head screws in there. Now tip my fixture up onto its side. Hold my finger on like so, and just thread them in till they're hand tight. And then you'll use a 1/4 inch Allen wrench to tighten them up. And that's all it takes for the assembly process. And then you'll notice here on the fixture, there's 3 separate rows of bolts. That will judge your height and set the height of your blade to give you the proper clearance for soldering your new tip on. They're all threaded from underneath. You can use a 1/2 inch wrench to initially move them up and down, because when the fixture is brand new, it's going to be kind of pinched in there, so it's going to be a little bit tighter. But as you use the fixture for a while, it will loosen up and you'll probably be able to thread them by hand. Now, when you are selecting the proper bolts to use, when your saw blade's sitting on here, you want all of your bolts to be below the surface. The only 3 bolts that will be up in the air are the ones that are closest to the outside diameter of your saw blade, but not hitting your carbide tooth. So that way you only have 3 selected sizes and the other ones aren't off just a little bit, changing your angles or something like that. When your retipping fixture is brand new, the stop finger will be required to be oxidized, so that way the new carbide tooth doesn't have a tendency to stick to it. Now, the only other time that you have to do that is maybe way down the road. If you start noticing the carbide tooth starting to stick to it, then just go through this oxidizing process to eliminate that problem. So what I do is I loosen up my clamp. I'll spin my clamp around so that way it's sticking about 2 to 3 inches over the retipping fixture. And you're going to take your acetylene and oxygen torch. And now when you have your heat for this, you want the flame, you don't want it flaring out, you just want a nice steady stream. And then you'll apply your oxygen to it to get it to a nice flare. Want to see some black smoke like that come up? And then you want to apply direct heat to just the stop finger tip and get it so it turns cherry red, and then let it air cool. And then just let it air cool, and then your tip should turn more of a purple color, and you'll know that it's oxidized. You'll want to let it cool for a while because it's going to be extremely hot. When purchasing your carbide tips, you have two options. You can get your tips that are just regular carbide tips. They're not tinned at all. There's no silver solder on them. Or you can get them pre-tinned. I prefer to get mine pre-tinned. The company does a really good job. They do a nice consistent little bead of solder on there. You can do it yourself. You can refer to the written instructions if you want to get them untinned. Then you have to apply it yourself, the solder on there. It's not that much more, and I would really recommend getting the pre-tinned ones. Now we can zoom in close and I'll explain to you what that really means. Now on your carbide tooth, you can see here that hump on the back. That is your silver solder that has already been applied to this tip. You can see how consistent and how good of a job they do. You can do it yourself. It's a little bit harder and more of a learning curve, and like I mentioned, it's not that much more to get your tips pre-tinned, and it makes your job a lot easier and you spend less time in your shop. When selecting your proper tip sizes, there's two styles of carbide tips. One is your standard conventional style and one's the European style. In the written instructions on the very back page, there are some recommended tip sizes to stock to cover a whole range of different blades that are coming into your shop. I get my tips from Sharp Tool Company. Their contact information is in the written instructions. You can also get them from Carbide Processors. I've talked with both companies. I like Sharp Tool better. I deal with Mike Moret. He's very knowledgeable and really helps you out when you're getting started. Now that we're zoomed in nice and close, I can explain a little bit more in detail on the two styles of tips. One is your standard conventional style, and on the face of the tooth it's going to come straight down and cut back to where the saw blade gullet and backrest will be. Now the other style is your European style, which will come down in the face and then slant downward a little bit and then back towards the gullet and backrest of your cast of your blade. Your European style, like this, your part number is always going to start with CW, and your regular standard style is always going to be just a W. Now when I'm matching up your existing tips to your new carbide tips, I'll first inspect my blade. I'll mark in black marker which tips that I'm going to be replacing, and I'll mark it on both sides of the blade, because down in the later part of the DVD you'll see that we'll be side grinding, and you're going to have to flip your blade over so it's nice to see which tips are exactly being replaced. Now you need to measure your height, your width, and your thickness on your tooth. So I'll use my caliper to check my height on the existing good tooth here. And I got 210 thousandths. That's more of a shorter tooth. A lot more of your saw blades are going to be a lot taller than that, but that's perfectly fine. And then I'll do my thickness here, which I have 0.78. And I like to keep a notepad off to the side, so I had 210 and then 0.78. And then you use your micrometer and you'll do the width of the tips. And this carbide tip is 95 thousandths. So I'll write that down. And then I'll look at the tips that are close to that size. You want to have your width being at least 10 thousandths more, so that way you can have 5 thousandths of clearance underneath and 5 thousandths up above. I do have one here that's 100 thousandths that I could use, But when you're first starting out, I would not recommend using something that short or that close to the other one. It's only 5/1000ths. So I'm going to use a 120 for thickness. It's a 281, so it's a little bit taller, which you want a little bit taller because you're going to be top grinding that down. You don't want one that's shorter and then it's not going to be the right height. And this is a 093 for as far as thickness, which is totally fine. You can have it a little bit thicker. If you have a 078, that's fine to use as well, but you can always face grind a little bit down, or if it sticks out a little bit, it doesn't matter. So that's the tip that I'm going to use. Now that we got our tip sizes picked out, I'm going to flux the blade. You want to put flux on the blade because that'll keep the heat from burning the blade. There is white and black flux. I have a white flux, and I've never used the black, but I have been told by many people that I talk to, existing customers, they like the black better because it does withstand a little bit more heat. I have never really had a problem with the white, but it's up to you whether you want to use the white or the black. When you get your flux, it's going to be pretty hard inside there, and you want to dilute it a little bit with warm water. So this one already has some in there, and I just take my flux brush and I just kind of mix it up. You don't want it like real liquefied, you want it more like a paste. So I'll just mix that up a little bit. Take a shop towel. Just clean off the back end of that quick. And then you want to take some flux and put it on your brush. And all your tips that you're going to be replacing that you got highlighted in black, you just want to put a little bit on there. And then you want to put some on the other side as well. You don't have to be real neat about it, just kind of get it on there nice, that way you don't burn that blade. Now that the blade is fluxed, I'm just going to set it over on the saddle assembly on the AV-40, and I'm going to let that dry a little bit. So that way it sticks onto the cast of the blade for a while, and then I'll set my heights for my retipping fixture. So now that we have our blade fluxed, I'm going to set up the side clearances to raise your blade up to the proper heights for your new carbide tips. Your center pin for your arbor hole is initially going to come in this positioning. This will do blades up to 16 inches in this position. If you do have, and you don't need the side support stand for any blades that are in that 16-inch range where your center pin is here. Now if you have 18 and larger inch blades, up to a 30-inch blade, this will retip. You can remove this pin and you can put it in the outside diameter on the very outside portion of the fixture, and now you have a lot more room to do your 18 to 36-inch blades. And this is where you need your saw support. You'll have it out here holding it up because you won't have those screws like you would if the arbor pin was right here. So if I were to set this blade up, let's say I would have 24/1000ths of clearance. Your table bed is going to be pretty level, so I'll set this on the side right here, and I'll use my saw set gauge or side dial indicator, and I'll just put it on the tip here. So I can go around the side, and I'll thread this up or down until I get my 24/1000ths, and then I will tighten this bolt underneath here a little bit, and that will have this side supported for that side of the blade. Now seeing we are doing a 12-inch blade, I'm going to put it back in the correct positioning. And then we have 3 rows of screws here that are inset through the bottom. When your fixture is brand new, it's kind of squeezed in on those bolts, so it's going to be kind of hard to move them by hand. So you will need a 1/2-inch wrench to raise and lower them. You want to select only 3. You want all your bolts to be below the surface except for the 3 that are closest to the outer diameter of your blade. But you don't want it too close where your carbide tip would hit that. You want just the screw head to hit the steel cast of the blade so it rotates smoothly but towards the outer diameter. So I have my 12-inch blade here, and I'm just going to set it down in here so I can realize which ones I have. And now right here I can already see that this bolt right here is really close to the outer diameter, but I know for a fact that it's going to hit that carbide tooth. If it hits that carbide tooth, there's clearance there. It's usually 12 to, 8 to even 15 thousandths. That gives you your curve. So I will select 1 in, so 2 in from the outside blade that I'm going to do. So now we had our notepad before, and we had 95 thousandths thick on our existing tooth. We have 120 thousandths on that tooth. So now we want to, which will be you got 25 thousandths. Now you want to divide that by 2, which gives you 12.5 thousandths. And then you want to take your side set gauge and you want to put it on your existing tooth to see what your clearance is. Right now this one is showing 12 thousandths of clearance. And if you notice on this blade, I kind of looked at it beforehand, this side is actually 13 thousandths. But this and the 13 thousandths is going to be side facing your plate. So now you want to take that 12.5 thousandths plus your 13 thousandths, which would give you 25.5 thousandths that you want to raise those 3 bolts to bring your width up, so that way you have extra clearance underneath there. So you'll have, extra clearance below and extra clearance above. So when you side grind that, you'll get that correct. Now I decided to go 2 in from the outside, and this one has been loosened up already. So I'm going to raise just that bolt until I get to my 25 thousandths. I'm going to do the same over here. Bring it up. 25 thousandths there. And this one, same thing. $25 thousandths. So now that whole blade will sit up level nicely. And now I'll set my blade onto here. And you should be able to kind of push down and you'll be able to feel that there's a gap in there. If you want to make sure that you're correct, you can take your existing tooth and you can set it on there and use your gauge. And here I am 12.5 thousandths above my other, no, I had 12 thousandths, I'm 25 thousandths, I'm sorry, above this cast of this blade, so I got 25 thousandths below, 25 thousandths above. And then you'll use your 3 bushings that you have. You have your 5/8, 3/4, and 1 inch. This is a 1 inch arbor on a 12-inch blade. So I will set that in there, and that will keep it nice and straight. And that's kind of how you set that up and get your proper clearances. Now that our flux is dry, we're going to remove the carbide tips with our acetylene and oxygen torch. We're going to wear safety glasses from here on out. when we're working with the torch setup. And I will thread down the diameter adjusting slide lock to help support the saw blade so it doesn't tip up. I'm going to bring it pretty much down, but I want to leave it a little bit loose so I can spin it to my next blades and real easily when I'm using the torch setup. So I want it kind of tight but not tight. And then we are going to apply direct heat right to the carbide tooth. Then once that carbide tooth heats up and turns red, we're going to take our stiff wire brush and we're going to knock out the carbide tooth. The stiff wire brush is also going to remove any excess silver solder that's in there and really clean that gullet nice for when you start brazing your new tips on. So now we'll turn it on our torch. Apply heat right towards the tip. And that's that. Now I'm going to take a look at them also and just make sure that there's not any excess solder sitting on there. And if there is, I'm just going to use a small flat file. And I'll tighten that down and I'll just go right inside that tooth and clean anything out of there. Some people will use the black resin bond wheel and kind of set it up like you top grind and clean it out with your resin bond wheel. I don't feel that that's necessary. A flat file is going to remove everything out of there. And if there is a little bit of silver solder, it's just going to help the other tooth stick to it, to solder in there. So it's not that critical. So now that we remove the old tips, we're going to braze on the new tips. You want to set your saw blade with your correct arbor size. I like to line my tips up in kind of like a row, and then I will use a flathead screwdriver just kind of push them, into that stop finger. I always grab one or two extra ones just in case when I go to solder it on and the flux, just something happens and it just doesn't stick well. I got an extra one. I can take the old one out and push it off to the side. I'll let the tooth cool down, so I'll go to a different tooth, and then at the end I'll come back to that tooth that didn't braze correctly. So now you're going to line up your stop finger to an existing tooth that's already there to get the correct hook angle. So I'm going to just match this up, and you want the stop finger, the very tip, to be just below the bottom of the existing carbide, just a little bit. So that way you don't hit the back side of that steel or anything like that. So I'm just going to line this up so you can, turn your blade like that and just kind of bring it right into position. Just line it up so the face of the tooth is even with the face of your stop finger. And then you're going to tighten down your clamp. And then, like I mentioned before, this is spring loaded, so if you're going to your next tooth, you can bring it in like that and like that. So now I'm going to bring it over to my first tooth. I'm going to first get it kind of set up, and I like to have these, like I said, kind of in position, so I can just slide it in here, bring it over, and pinch it into the gullet of the saw blade. I always have a tendency to kind of cap down just to make sure that that carbide tip is sitting nice and flat on the retipping surface, so that way it doesn't want to kind of cock at an angle, so you keep it nice and square. So I'll have one set up. Now also when I'm retipping, I'm going to keep my hand over here just to stabilize the blade. You don't want to take and put pressure into the stop finger, because if you do that, the solder, once it heats up, you're going to squeeze the solder out of the joint. You want to just stabilize the blade, heat up the tip. You want to heat it right at the carbide tooth area, pinching over by the stop finger. Once that solder starts to liquefy, I'm going to take my torch tip and I'm going to just swoop it down a little bit so that way the solder kind of falls down into the gullet. And you'll see the blade kick in towards the stop finger, knowing that it's brazed on there correctly. So I'm going to turn on my torch. Now I always keep my screwdriver right off to the side. I'm going to braze it. And bring it over to the next one. This one will fill it up. Finally heat. Now that one didn't stick, so I'm just going to keep it off to the side. I'm going to let that tip cool down, and I'm just going to go on to my next one. And I'll come back to it later. Now we'll go back to that's the last tooth that I had, except for the one that did not take before. So I'll go back to it. And I can see that there's a chunk of a little bit of silver solder stuck in there. So it's not allowing it to pinch in there nicely. So I'm just going to bring it back over onto my AV-40 and just take my file and clean that back out and flip it over here. There you go, I re-cleaned that out. And I will get this back reset up on that one tooth. Normally when one doesn't take, it's usually you don't get a chunk stuck in there. And I think the reason why that happened to me on that one is I didn't let it sit for a second to let it cool. As I pulled away from it, it just kind of stuck with the finger a little bit. So I'll go back to that tooth. Get it all set up before I turn on my oxygen. And turn on our torch. And finish that last one. And that's the brazing process. Now, to clean off the excess flux that's on there, I just take it on my wire wheel of my bench grinder to clean out, you know, the tooth, you know, just like you would when you're originally cleaning your saw blades. Get in between the gullets, get the sides, and if there is a little discoloration on your blade, when you take it on your wire wheel, it'll help remove some of that to kind of blend it into the original cast. If you have a little burn mark, it's not too big of a deal. It's not going to affect the cutting. It's not going to affect the tooth or, you know, moving the cast of your blade. So it's totally fine if you have a little discoloration, but you can kind of see in here that I don't. And then also too, when you're taking on your wire wheel, if you have a bad solder joint, the tooth will fall out, which is a nice way to, you know, do it before you get to the point of side grinding and then kind of coming back over here. So it's nice to just clean it up right away. So now I'm going to show you how I kind of use the wire wheel on the bench grinder to clean all that off. I'll just turn it on and just put light pressure into that blade and just remove all that stuff that's on there. And I'll do a couple tips behind and in front too, in case anything got in those tips as well. You can see that it's nice and clean, there's no discoloration or anything like that. I'll just repeat the process over here. Now just get a little bit of the top here. All cleaned up and ready to side grind. Now that we've got our new tip soldered on, we're going to show you how to demonstrate how to side grind. We have our 5-inch flaring cup side grinding wheel. We actually consider it a multi-purpose wheel because if you have this wheel, you can also grind your carbide joiner and planer knives as well. So it's a nice wheel to have. Another thing nice about it is it sticks out so much farther than a regular, you know, side grinding wheel or top grinding wheel. So you don't have to move the motor down as far when you bring the motor up to side grind correctly. Now, if you don't purchase our multi-purpose wheel or our side grinding wheel, like I like to say, I would recommend using your top grinding wheel. Because your face grinding wheel, when you face grind a saw blade, is always going to move fluently back towards the cast of your wheel. When you top grind, it's going to go at a little bit of an angle. The wheel's going to wear. So that's going to be kind of the same wear pattern as if you are side grinding. I like the 5-inch wheel. You can see a little bit better. It's also a little bit more coarse. Instead of a 400, it's a 220 grit. So it eliminates a little bit more of the side grinding material a little bit faster. So put it onto my arbor. Now with your AV-40, you will have your side grinding spacer. It's got two little indents out, these little pins that will fit underneath your saddle assembly. So if you loosen up your slide, I'm going to bring this off to the slide sideways a little bit, slide it forward so I can let my blade tip down. And there's two pins in the back and they'll sit right down in there. Now what that does is now it tips our saw blade down at an angle about 3 degrees. Because your carbide tooth, that's your existing one, it's got a 3-degree bevel coming from the very top down towards your center arbor hole and from the face of your blade back towards the cast of your saw blade. So there's a double compound bevel. So when I set up to sharpen this one, I want the motor to be not at 90, I want it to be at 87 degrees. So that way you get that 3-degree pitch, you get your 3-degree pitch this way. So here I'm going to bring my motor up. Loosen my pin. I'm going to bring this up to 87. Like so. Another thing I will also watch for is I'll kind of feel the side of the blade, or the carbide. A lot of times the carbide will have a little drop off going towards the cast. If it's pretty much flush, then I will switch my degree a little bit and go about 2.5 degrees, so that way you don't grind into the cast of your blade to make it look nice. As long as you have that relief, it doesn't really matter if you're 2.5 or 3 degrees. But if it is, you have a lot of clearance, then I will do the 3 degrees. So I'm going to switch this one just a little bit because I'm a little bit thinner. Right there. And then I will put my stop finger in, so that way, or tighten my blade down first. And then I'm going to position my stop finger just like I would when you top grind. Same exact way. Got a little bit of an index. And then I'm going to keep my slide straight with my rods down here. So that way I'm always kind of going in straight. I'm going to slide this back. Got a little relief. I'm going to lock that down. Now I'm going to loosen my cone, because I got everything stationary now. I'm going to loosen my cone to position my tooth to my grinding wheel. So I'm going to loosen my cone just a little bit, about a half turn. I'm going to bring it, because now I can move my stop finger rod around. I'm going to loosen my front stop, and I'm going to bring it into my wheel. I want to use more of the side of the wheel here, because if I'm in the center, it's going to have a tendency to grind back farther. You want it so the wheel grinds the tooth and just misses your cast of your blade. So I'm going to bring this lower, loosen my tensioning there, and thread this down. And after I kind of get this set up, we'll move the camera around to the other side so that way we can get a good picture of this, close up. So now I brought this motor down here, and you want the wheel positioned off to the side, kind of like I was mentioning, so that way it's not going to hit your other tooth. For instance, if I would bring this down farther, and let's say my stop finger was there, you can tell that I'm going to start grinding those other tips before I'd even hit that one, because your wheel is slanted to the side. That's why you want to use more of the side of that blade, or the grinding wheel. I'm sorry. Let me get it set up there. Now I'm going to lock my cone. And then I'm going to bring my blade forward and set my front stop so that way your diamond section of your wheel goes right past to the edge of the carbide and not any farther forward, otherwise you might go into the cast of your blade again. Bring it forward. Set my stop, and now we're set up. Now that we got that set up, like I was mentioning before, we have a 3-degree angle going each way. So you can kind of see, and we're going to check our clearance to know what height. We already determined it was 12 on one side and 13 on the other side. So this side here is it's about 11.5, right around there. They're all going to be pretty close. Yep, about 11.5. And if you take this here, you can see that as I move down that tooth, you can see that it lowers and it drops off right about the 5 range. And if I bring it back away from the blade, you can see that it falls off as well. So that's why we are side grinding to match those two angles. So now I will check my blade right now, and I know that we had about, right here I got 28 thousandths. Sometimes the new carbide tooth, even though it says 120 thousandths, it might come 123. So that's why we might have a little bit of variation there. So now that we have it set up, I'm going to turn on my motor. Now that I got that all kind of cleared up and I got the angles set on there with side grinding it, I'm just going to make sure that I have a nice proper flare, which I do that way, and which I do that way. So we should be good, and we can continue to side that, grind that down. Now, because your tip is sitting higher, because you're using a taller tip, you want to make sure when you set this on here, you look at the alternate bevel. Like here I got the bevel pointing upward, this one's downward. So the height right here is going to be different from this tooth to that tooth in the positioning. So this one, the point is going to be the upside, which makes your tooth longer on this side. So I want to make sure that I kind of position that in the same spot. Like I don't want my very tip to read my 12 thousandths, because once I get into the position where I'm going to be done top grinding it, then I'm going to be too low. So I kind of want to just, you just got to get a rough guesstimation and be kind of what's similar. I kind of use a reference going from this cast of my steel kind of upwards, and I can see about how far up. So I'll just hold that there, and right now, because you can see right now that if I would hold it here, we're at about 27 thousandths, and if I would bring it up, you're almost at 28. So it will change. So just wanted to point that out. I kept grinding that down until I got it pretty close. And you can see right now that we're looking for that 11.5 thousandths. I just got to take up another pass or two because I'm at about 13. And we can see that we do have that nice flare and drop off at about 6. So if I remove that extra thousandths, it's going to drop off at the 5, which what we had on the existing teeth. So I'll just turn it on and take a couple more swipes. There I got 11.5. So now that tooth is done, and you're going to just repeat the process and do all the other 5 tips. And then you just bring it over to your next one. You don't have to reset anything up. The only thing you got to do is bring your motor up a little bit and start side grinding. And then now I will show you how to set up for the other side. And this is, some people ask me questions, why are there 2 stop fingers? This is going to be the reason why. Because now when we do the other side of the blade, we have to flip our blade over. Loosen this down. Reset this up. And now we have to switch our motor to 93 to bring it over to the other side as well. So I'm going to do that right away. I'm going to set my stop finger. A little bit more. Right there. And then I'll loosen my cone, and again you want to use the side of the wheel. So I'll loosen my cone and position it kind of like I had the other one. Bring that wheel so it gets kind of close. Tighten my cone there. I set my front stop, and then we'll see if we can zoom in and get in kind of more of an exact location. Now we got this wheel in this positioning. Get a nice picture of that. And then you'll be using more of the side of the wheel. And then with my front stop, actually I should back that up just a little bit, right about there. And you can notice that the wheel will not make contact with that tooth behind it. And we're just going to repeat the process. Turn the motor on. And you can see here again, we should have that nice flaring. Going both ways. This one might be hard because we have the cast of that blade in there, and I'm going to want to fall into it, but you can see that it flares down each way, and you'll just side grind that one. You want to check your clearances on this side because the other side was at 11.5, but you might have a variation. So this one, I think when we checked it out earlier, you get that, I'm at about 12.5 thousandths. So it's a little bit different. It's not always going to be the same. Sometimes on blades I've seen them 11 on one side and 14 on the other side. A lot of times I do see it where it's 12 and 12 or 15 and 15, whatever it might be. In this instance it's about a thousandths different, so you bring this one down to 12.5 thousandths and repeat the process of side grinding on each tooth. Now that we're done side grinding, we're going to sharpen the blade just like regular. We're going to face grind it. I want to show you some helpful tips for when you do get to the top grinding portion of it that I like to use, because your tip is a lot higher than your existing tooth. So what I'm going to do is this is a 15-degree alternate bevel blade. I already have it preset up, and I'm going to bring it my grinding wheel so it doesn't make contact but almost touches the existing tooth. Then I'm going to use our motor stop clamp, which is right here. You can see that it's hollowed out so that way it fits onto the motor slide area. I'm going to put it right on there, and I'm going to slide it back so that way it makes contact. And I hand tighten it just a little bit, and then tighten it down just slightly. So now what that does is when I go to this existing tooth, because obviously you're going to jump right into your grinding wheel, I can back this up and I can just keep moving my motor in and in and in until I make contact with my motor stop clamp, and then I know that I'll be pretty much at the same exact height as my other tips. So that way when I do my top grinding to all my teeth, I don't have to go and check this one for different heights and heights and heights. I would like to thank you for your most recent purchase on our AV-38 retipping fixture. Again, a couple accessories that we do have is our side set gauge and our side grinding wheel, which you can also do joiner and planer knives. On the back of the written instructions, again, like I mentioned earlier, there are some recommended tip sizes. A company that I like to use, they're very knowledgeable, their phone number's in there. And I also get my flux and my plastic seal dip from the same company, so I don't have to use a couple different vendors. If you have any questions at any time, you have my contact information, and please feel free to call me and I'll help out with any questions that you might have.